extrema, if any, of the function, and use the second derivative test if applicable. Okay, so first order of business, find the critical points. So we want to solve 3x squared minus 9 equal to 0. I think dividing by 3 is a good move here. All right. And so what's that tell me? X squared is equal to 3, so x is what? Plus or minus the square root of 3. You guys with me? Those are my critical points. Now, this question doesn't say anything about intervals of increase or decrease, right? So if I don't want to, I don't have to make the sign chart. I can just stay ignorant of where it's increasing and decreasing. That's your business if you want to be ignorant of that. I mean, it's our prerogative here. It says for us to use the second derivative test, right? So what do we do? Calculate the second derivative. G prime prime of x is what? It's 9x. Sorry, it's very interesting to me how many people are not aware of who Rush Limbaugh is. It's really hard. I can't. It's fascinating to me. Oh, sure. I differentiate this up here. Oh, I'm sorry. Yeah. Somebody take away my license to differentiate. It's a sad day for differentiation. It's okay. I'll recover. Okay, so then you take this thing and you plug in your critical points. G prime prime of the square root of 3. G prime prime of minus the square root of 3. What do you get? You get 6 square root of 3. You get minus 6 square root of 3. This is positive. This is negative. What does that allow us to conclude? So let me just make the conclusion. Therefore, by second derivative test, g of the square root of 3 is a blank. Therefore, by second derivative test, g of minus the square root of 3 is a relative blank. I could have put relative blank up here too. I'll do that. Relative blank. Fill in the blanks for me, please. It's human nature. You want to say that the positive is the maximum and the negative is the minimum, but that is incorrect. Because this is what x squared looks like. This is what minus x squared looks like, right? Right, so here we have y prime prime equals to 2. Here we have y prime prime equals to minus 2. The critical point is the origin. Which one's a minimum? Which one's a maximum? Right, the minimum is the one that's positive. The maximum is the one that's negative. And that's a second derivative test. So since the second derivative is positive, this is a relative min. This is a relative max. And there you go. Now, what is the actual value? Yeah. Oh, well, there you just got to plug it in. They're back to pre-calculus again here. So g of the square root of 3, which is sometimes the hardest part, right? Indeed. Yeah, should we plug it into the function or the derivative? What would make sense? The original function, right? We're analyzing the minimums and the maximums of the function itself. So I plug it in there, whatever it is. Ugly number. Oh, I guess it's just minus 6 root 3. But whatever. Yeah?
So it's the same thing on number 9.
Oh, I'm sorry. One more point. You're fine. I just looked at the answer key. I want to mention something. So that's the y value, right? The actual minimum, the actual point is then where? The point at where there's a relative minimum would be what? It would be square root of 3 comma, minus 6 root 3. That would actually be the xy coordinates of the point. Because the answer they're looking for is like x comma y, so you need to, you know, yeah.
I'm pretty sure I did the same thing on mine and it didn't get the right answer. It's slightly different numbers.
I don't know. What was your question? Well, I'm looking at hers.
Minus 15, and I tried a couple different combinations of pluses and minuses in case I was doing something
No,
wrong.
it's there's always plus minus minus plus.
Oh.
They're flippity floppity. See here, plus minus. The one is plus minus, the other one's minus plus. What it is, guys, is this thing is x times x squared minus 9, which is x times x plus 3 times x minus 3. So I can cheat and tell you that this has zeros here, here, and here. And what it's looking like is this. Here's the maximum at minus root 3. Here's the minimum at square root of 3. And this is at, square root of 3, comma, minus 6 root 3. This point is minus the square root of 3, 6 square root of 3. That's what's happening. This is actually the function. I can't usually do that. It just happens that this one's easy to factor, so I can actually just draw the graph like that. What was your question?
For number 9, I went ahead and I found the derivative, but
Ah.
I had a hard time finding the point because the derivatives are such odd.
Yeah, this one's a little bit different, the structure of it. Let's analyze this one carefully. I like this one. This is another example of a rational function, not just a polynomial, right? So it's a relatively simple rational function, but still, we'll see. So number 9, we have h of x is equal to x squared plus 2 over x for me. Now yours might be a little bit different. Oh, same thing? Good, good, good. So we're supposed to find relative min-max, use second derivative if applicable. So first order of business, find the critical points. Now, this, if I set this equal to 0, what's that tell me? 2x is equal to 2 over x squared, right? Which tells me then that x cubed is equal to 1. And the only real solution to that is what? Yeah, cube root of 1, just x equals to 1 is the only solution there. Another way to see this, all right, another way to see this would have been the following. I can take the original expression and I can rewrite it as 2x cubed minus 2 over x squared equal to 0, which would give me 2 times x cubed minus 1 over x squared equal to 0. I mean, I don't know if that's much better. Let's not even look at it. Let me erase it before you guys see it. Look away. Look away. It's not helping. It's not helping. Okay, so our critical point is 1. Oh, I guess we should calculate the second derivative then, huh? What's that? H prime prime of x is what? 2 plus 4 over x cubed? All right. And then, let's see here. That tells me that h prime prime of 1 is 2 plus 4 over 1 cubed, which is 6, which of course is greater than 0. Therefore, h of 1 is relative minimum. Indeed, the point would be 1 comma h of 1, right? Which would actually be what? Plug in 1 into h, we get 1 plus 2 over 1, 3. Yeah. So there it is the point where the relative minimum is. Of course, here they just ask But here they just ask us for the relative minimum, the value of the relative minimum, right? They don't actually ask us for the point. So the answer here is just, that's the point. You gotta be careful what kind of answer they're looking for. Here they just want the relative minimum value itself is 3. So the answer actually is 3. Is there a relative maximum? It does not exist, no. This function is fun to graph. It looks like this. So here is the graph. Let's say this is the graph of y equals x squared, right? And then you're adding 2 over x to that. So of course y over x squared has this like stupidly large asymptote, right? So it's something like it follows the parabola and then drops off, has this giant asymptote like that, and then it does something like this. So this green is the graph. It's something like you're just adding 2 over x to the x squared function. So it's got a vertical asymptote at 0, and it's got no absolute maximum. It's got no absolute minimum either, because this drops down as far as you want. But we found that this point is at 1, and its value is 3. That's what we just did. Sorry, I love this stuff. Do you guys have another question?
I have one more question.
What's that?
I have one more question I want to check on.
Oh, go for it.
13 on the same homework. I found the horizontal asymptote.
Ah. I like your choice of questions. This was the one I was planning to cover, if nothing else. So perfect. Although I'm not entirely certain we have enough time to do this justice, we will try. So number 13, what are we supposed to find? Horizontal and vertical asymptotes, great. So the horizontal asymptotes have to do with the large scale behavior of the function when x is much, much larger than a finite value, or much more negative than a finite value. And just long story short, if you look at this, we've got x to the 4th upstairs. We've got, if you look at the leading terms, the numerator is quartic, the denominator is cubic. That means for large x, this behaves like x, because the leading coefficients are 1. No horizontal asymptotes. So the limit as x goes to plus or minus infinity of f of x is equal to, well, plus or minus infinity, actually. So no horizontal asymptotes. Okay, there we go. That's settled. Now, how do you figure out where there are vertical asymptotes? Yeah. Well, see, that's almost true. That's almost true. I mean, what you're saying is just about right, but there's one other thing that we should talk about. For example, here's a simple example before we cut our teeth on this one. What if I had f of x equals to x squared minus 9 over x minus 3, or it's the other way around, x minus 3 over x squared minus 9. Well, you see what that would be. That would be x minus 3 over x minus 3 times x plus 3. So that would be 1 over x plus 3 for x not equal to 3. So what does it mean when there's a equal number of factors in the numerator and the denominator which cancel out? It means it has no effect on the function anywhere else except for that value, in this case 3. So it's what we call a hole in the graph. So there could be a hole in the graph. I don't know. I have to, and I can't tell that, right? That's probably what's going on here. Otherwise, the question's too easy. This is x squared times x squared minus 1. Do you agree? You see, aha, indeed. In fact, this has 2 holes. This function has 2 holes in the graph. We have a hole in graph for x equals to 0 and x equals to 1. Both of those points, the division is balanced out either by an equal or greater power of the same factor in the numerator. In fact, this hole in the graph is actually at 0. The other hole in the graph would be at, so, you could define another function, g of x, equal to x times x plus 1 over times x minus 1. Oops, excuse me, not times x minus 1 over x plus 10. This is what's called the reduced function. The reduced function, how you get the reduced function from the function, you just take the graph, and anytime there's a hole, you just fill it in. So this is f of x with the holes filled in, which just means you cancel out the offending thing. Yeah, so, just getting back to the original one, this cancels that, right? This cancels that. And so the only thing that's genuinely division by 0 in the formula is the x plus 10. The only vertical asymptote is x equals minus 10. That's it. So, yeah. But if you want to know where those holes were, there's a hole at 0, 0, and there's also a hole at 1, comma, g of 1, whatever g of 1 is, that's where the hole is at 1. Well, anyway. Trust me, my opinion of you has not changed on the basis of whether or not you know who Rush Limbaugh is. I'm just genuinely curious about who's been aware of... He's a conservative talk show radio host. He's responsible